So good evening, dear participants. Welcome again after the break, and sorry for the change in schedule. The change was due to some unforeseen academic emergency, and we have with us again Dr. Salman Sadullah Usmani. So Dr. Salman will be taking module on machine learning for bioinformatics. So welcome, Dr. Salman, and I am handing over session to you, sir. Over to you, sir.
Thank you so much, Professor. And sorry for the delay because I have to reschedule it. I have an emergency meeting, academic meeting, so I have to reschedule the session. So today we are going to talk about it will be kind of introductory to machine learning.
Sir,
So
Dr. Salman, your voice is not so much audible.
Okay. Is it audible now?
Yeah, you have to speak a little bit loud.
Okay, that's fine. So I was a little bit anxious too while I was making my presentation. So it will be much more kind of communicating with each other. So that I could know whatever I am delivering is up to the mark or not. So my first question is, could the participant raise the hand, those who have the mathematical background in their graduation or in the masters, or even in +2? Those, please raise the hand if you have a mathematical background. Okay, Keshav, Somesh, and okay, two guys. So that was my actually curiosity while I was preparing the presentation, because most of the time most of the workshops are based on biological data and other things, and the machine learning is something which is talking more about the mathematics. So I was very much anxious whether I should include more mathematics or not. I haven't included in my first presentation because I know 90 to 90% will be from the biological background. So, and I was right. Just two guys have the mathematical. Could you please unmute Somesh and Anish, and could you tell me how much you guys are from the +2, or you have done your graduation masters in the mathematics? Or you could write down in the chat box. Okay, it's +2. Okay, so it's still not too much mathematics involved. What the machine learning is requires. So that's fine. We'll go with the basics and we'll learn how to implement the machine learning algorithm into our biological data. That will be enough for our presentation. For this workshop, that will be enough. Okay, so I hope my screen is visible to everyone. So both are only the +2 level of mathematics. That's fine.
Yes, sir. Your screen is visible.
Okay. So today we'll just talk about the introduction to the machine learning. I'll try to deliver each and every concept and whatever the terminology which is coming into this topic. I'll make sure that you came across all these terminology and understood with a very clear and real life example. That's my goal of today's presentation only. If there will be any hardening in understanding anything, you could raise the hand, or after 2 to 3 slides, or you could say after one particular topic, I will pause my presentation and we'll discuss if anything is not understandable. Then because if you know if you'll understand each and every wording, then it will be better for tomorrow when we'll do the much more hands-on to some biological data. So what's the problem with this? Okay, so these are some quotes about just to give you importance why machine learning is important. So this is a famous quote by Andrew Ng. And if you are not aware who is this Andrew Ng, he is the co-founder of Google Brain, as well as you must have known about this Coursera application, Coursera web, education platform. So he is the co-founder of both the Google Brain as well as Coursera, as well as one Chinese company of Baidu, not the Baidu, with Shah Rukh Khan ads actually. So what he said that just as electricity transformed almost everything 100 years ago, today I actually have a hard time thinking of an industry that I don't think AI will transform in the next several years. So that's what it means. And we see this in the real day-to-day life. All this marketing, or you could say the finance sector has seen a tremendous growth of the AI. We have seen the AI in the role of education sector, all these Coursera app, Baiju app, or whatever the technical educational platform or app you are using. It actually uses artificial intelligence in their background, and they suggest you the course depending upon your what you have given the data input. If you are coming from the biological background, you will see that you are getting the suggestions from biological courses. And in the healthcare, definitely AI and machine learning has given a good transform in the last decade. So what he has said, this statement is I think of 3 to 4 years back. So whatever he has said, we are visualizing this into the today's life. And second one is this Larry Page, who is also a co-founder of Google. And what he said that artificial intelligence would be the ultimate version of Google, the ultimate search engine that would understand everything on the web. It would understand exactly what you wanted, and it would give you the right thing. We are nowhere near doing that now. However, we can get intimately closer onto that. That is basically what we work on. So what that is mean, because he's a founder of a co-founder of Google. So he want to say that, okay, Google is still using the artificial intelligence and the machine learning. So you must be aware of the Google Voice Assistant and other things. But in this statement, what I understand that he wanted to show that, okay, we are using the artificial intelligence, but it is not to the precise up to that mark. We still have to precise that. Let's suppose that you must have observed it if you are observing it carefully. So if 10 to 15 years ago, if I just want to type who is the Prime Minister of India, so we get some pages or other thing. But right now, if I just type on the Google search box who's the Prime Minister of India, I'll get a one answer. It's Narendra Modi. The name will pop up. So now it is precising with the answer instead of redirecting me to the Wikipedia page. Although we will get the Wikipedia in the second or third option, but you see the popping up of the exact or a precise answer is nowadays coming on, and this transformation has taken place within 2 to 3 years. If you have observed it, so that's what it means, that artificial intelligence and the machine learning is learning from the data and is to give you the most accurate as well as precise answer. And if you are aware of using the Siri app or the Alexa other things, so initially when whatever question you ask, it will give you a long answer. If you ask what is the weather, so he'll say, okay, the weather around the US, or I mean the answer will be much longer. But nowadays it is much moving to the precise answer. If I ask today what is the weather, he will say it's cold. Simple. So moving to the precise answer is something what he has talked about in this statement. Now coming to another statement by Mark Cuban, who is one of the billionaire and in the under 100 Forbes list of top richest guy, and is also the main investor into the Shark Tank. Shark Tank is actually a US based reality program, and in India it has also been, I think, started from the last year. So he's well known Shark Tank investor. What he said that artificial intelligence, deep learning, machine learning, whatever you are doing, if you don't understand it, learn it, because otherwise you are going to be a dinosaur within 3 years. That is what he has said. He's a rich and known entrepreneur in the world. So I don't agree with his statement, because you are not going to be a dinosaur within the 3 years, but obviously each field is growing and each field is applying machine learning and deep learning or the AI into their domain. So it's not that if you don't have the mathematical background, if you don't have the computer science background, you should get rid of this machine learning. Try to learn it. I too have a biological background, but we can't ignore the machine learning things. We have to learn it, because the next few years still you'll see so many research and other things is going in the machine learning thing. So okay, you can't be expert into that, but learn the basics, so that if you are talking to some biological people or some in some conferences or in some problem, and they are talking about the machine learning, you should not be the out of the box. You should know what they are saying. Actually, everyone must have this much of knowledge. So this is some quotes what I have talked. And now coming to the main presentation. Okay, there is another confusion in the last three statements what I have talked. We have come up with 2 to 3 words like artificial intelligence, machine learning, and deep learning. Even to some guys who are working in the field, when I discuss this, they are confused with these three terms: what is artificial intelligence, what is machine learning, and what is deep learning. So this is just an image which is to understand what is. So if I talk, the artificial intelligence is a much global term which include machine learning as well as deep learning. So if you see, this is the bigger circle is artificial intelligence. What is this? This is, if I define it in a bookish word, it is just the ability of a machine to imitate intelligent human behavior. So the concept of the artificial intelligence is coming from the intelligence of the human behavior, how intelligent we are. So this is the same thing the machine or the computer try to imitate to give you the solution of your problem. So that is artificial intelligence. And within the artificial intelligence, there is a field or there is a domain within the artificial intelligence, which is known as a machine learning. So that means application of AI. It's an application of AI that allows a system to automatically learn and improve from the experience. So, or if I break this word machine learning, so it will learn from the past experience. So the machine is actually learning from the past experience and then try to predict the outcome for the new experience or for the new data. And then within the machine learning, the new and upcoming domain, this has been talked from the last decade, deep learning. So this is an application, or you could say a part of machine learning, which uses complex algorithm, and this mimic actually the neural networking to train a model. So deep learning is much more based on the how. So the concept of deep learning is coming from how the human neurons or the neuro system of the of human system has evolved and how it interacts. So all the concept of the deep learning is actually coming from the neuronal behavior. So this is a part of machine learning. So I hope it's everyone has cleared what is artificial intelligence, what is machine learning, and what is deep learning. So don't be confused when someone is talking. If someone is saying that he's the expert in deep learning, so that means he is dealing with a very specific concept. He is dealing with much more of the neural networking and other things. He is not dealing with some basic machine learning things. So our purpose is to give you a much more introductory and a glimpse of this machine learning today. And then we will also try to explore and hands-on with some data and applying the machine learning. So I'm not going to talk in this presentation about the deep learning. This is much more complex thing. So if I'll talk about deep learning, so that will be much more harder, because in the first lecture only I asked how many are the beginners. So most of the guys are the beginner, but we'll go in much detail, and that will be enough. That will be enough for you to deal with some biological data. Okay, now I'm coming to the definition of machine learning. What is the definition of ML? So ML is an application of artificial intelligence. Okay, that I already said, that's the part of the AI, which provides system the ability to automatically learn and improve from the experience without being explicitly programmed. So that I already said. So ML actually learn from the past experience and execute whatever it has learned. So it focuses on the development of computer programs. So that means you write some programs based on the data, whatever the input data you provide. So it learns from that data and predict what the question you are asking, what's your query. That is the focus of the machine learning. So optimize the performance criteria using example data or the past experience. That's what I have said. So in the machine learning thing, two things are much more important to know. One is basic stats. At least you should know the basic stat, because from that only you will inference from the sample. From that only you will inference your results. And obviously you should have a little bit of knowledge of computer science, because you will write some codes, you will execute those codes. And I'm sure from the past 10 lectures, you must have been got a glimpse of Python and other coding. So that is enough to execute your machine learning algorithms. That is enough, because I have seen the lectures recording and other things. I mean, that's enough to execute your codes. So you must have the knowledge of statistics as well as computer science, because these algorithms will solve your optimization problem, and it will represent and evaluate the model for inference. And we will see in the in our next lectures how when we'll build some models and how we'll evaluate our models. So you'll see the little bit of role of statistics as well as coding. Now, whenever I'm talking about learning, so what does learning mean? So what we talked about when we talk about learning. So learning is something. So you you make a model, or you learn a model, you make a model which learn from the data. Whatever the data you are giving, it learn from that data. So this is the concept of learning. And in this world, whatever the era we are living, actually the data is very cheap nowadays. It's not the data is very you could say, but expensive, but the data is very cheap. Everywhere, every domain is flood of the data, but the knowledge is very expensive, and very limited guys have that expertise into that particular domain. So data is very cheap and abundant. You will get the data from anywhere, and you have to apply your knowledge, and then that is about the machine learning. So let me give an example of social media platforms. So everyone has this Facebook or Twitter or whatever the things. So the data is very cheap. With some 100 rupees recharge, you are giving all of your data onto these social media platform. So let's suppose in the India there have been 100 crore population, and some 50 or 60 crore are using the social media platform, and they are uh, giving each of their information, their birth date, their gender, their what they like, what they dislike. I mean, everything is on the social media platform. And even a master MTech guy of the computer science, they could download the data from the Twitter or the social media platform. They used to do this type of dissertation into their MTech or their MS programs, and they try to learn from the data, or they try to ask some specific question from that particular data. So the data is very cheap. Another thing could be, if I'll give example how this data and will give. So this is an example taken from the Amazon.com. So what they have observed, that those people who have watched the movie The Da Vinci Code, they also watched the movie The Five People You Meet in the Heaven. So this is their expertise coming from the data of the people of interest, what they have watched. So that means learning is actually building a model that is good and useful approximation to the data. That is what all about this. And you must have observed that if you are using some, okay, we'll talk about this later. So what I said about the data is very cheap. So there is so many platforms where you could mine the data, like the guys who are in the retail or the finance, they used to do the market-based analysis, customer relationship management, and other things. So all your data of your credit score and other things is available, is easily available to these firms, and they just analyze those things. Because you must have read some survey about that Indian guys are from the lockdown or from the pandemic, there are much more interest, like 30 to 40% investment had been increased in the share market. It has been increased in the crypto market. So this is the data coming from some sources, and you get the news if you carefully observe these things. Okay, so 30% Indians have now have invested in the crypto and other things. So this is all about the retail marketing, and as well as finance marketing. And then manufacturing, obviously the optimization and troubleshooting is the part of manufacturing agencies, and same for the telecommunication, but we'll much more focus on the medicine, the bioinformatics. So you will see from the last decade, the medical diagnosis is using heavily on the artificial intelligence. So there have been a lot of development where they do the image analysis, and try to predict the outcome of a personalized outcome of a disease, and they try to cure it through the personalized medicine. So the medical diagnosis to the treatment is heavily using this artificial intelligence nowadays. And same for the bioinformatics, it has been using for 30 to 40 years, this motif alignment as well as epigenetic clock and other things. So this is also the data is easily available for the bioinformatics. And search engine, you all know that whatever the search word, whatever the keyword you are typing in the web mining, you will get the suggestions related to that. Let's suppose that if I'm typing some news related to India, although I'm sitting in the US, but whenever I open my Google, I'll get the flood of news coming from the India. It's not that I just have typed the search right now, but yesterday or a week before, I have typed the news related to whatever the news related to my city or my country. It has been flooded with the search engine to the web mining here, although my location has been changed. So all this is actually using the artificial intelligence. If we carefully observe, so this data is very cheap, and they are, people are using our data to mine the things. So this is application to reality. So as I said that, automatic language translation, you see that there have been tools where you say something in your native language and they translate it. So that is also based on the AI and machine learning. Medical diagnosis, I already talked. Stock market trading, I already talked. this Tesla self-driving cars. This is a very good domain, and research is going on. When I was in Triple IT, there was a guy on the MTech who was also doing his dissertation into the self-driving car, and he's applying some machine learning. His project was very interesting. I don't know whether it was successful or not, but his project was very interesting. And then Alexa, Google Assistant, and Siri, so they also take the voice command, and that's purely based on ML. And Netflix and Amazon. So I said that whenever you are using these streaming platform, okay, let's suppose I'm much more fond of seeing the movie of Telugu diaspora or the Hindu diaspora of the Bollywood, and the domain what is like is thriller instead of romantic movies. So whenever I'll open my Amazon Prime account, I'll see that they will suggest me to watch the movie based on the thriller domain instead of the romantic domain. So that's how they use your data, what you have done in the past. So they suggest you based on to that. So this is also using the machine learning. And LinkedIn, Facebook is very obvious. If even I type, I want something like qualify, say if I want trimmer something, if I typed into the Google, I just have typed, okay, I want to buy a trimmer online. So I just type in the Google, but next on the Facebook, you will see that you are getting the ad from different companies of the trimmer. So that's how they are using your data. And this DeepMind is a very good tool. I think it's came in the 2017 or 18, and they have updated in the last year, 2021. So this is coming from the healthcare, this tool. So this is the protein structure prediction tool. So there is always, after 2 years, there is a competition known as CASP, where from all the world you will submit your protein structure prediction tool. In the bioinformatics, this is the oldest domain of predicting the protein structure, and it is highly recommended. Still a lot of things has to be done. So the DeepMind last year outcast everyone, and it was the number one. So tools to predict the protein structure. In the healthcare also, this is coming, and this is one example of coming from the reality. Okay, so this is all about a basic idea what is data mining, what is machine learning application, and what is their reality. If there is any question, if you want to discuss, we could go for 2 to 3 minutes. Then I'll go much a deeper layer. What are the types of machine learning algorithms? If there is some query, you can write down in the chat box. Or guys can raise their hands if there is any query. They can raise their hands. Somesh has raised their hands. Okay, you could unmute yourself and ask. Somesh Kumar, if you have any specific query, you could unmute yourself and ask.
No, I do not have any specific query.
Okay,
Thank you.
So
Sorry.
you have actually raised the hand. Okay, that's fine.
Yeah.
So now we are. I am moving to the. Okay, there is some question.
There is some question in chat box.
Yeah, there is some question in the chat box. Can we have few examples of machine learning in genomics? Obviously, we will have the machine learning in genomics. We will have the examples into this into the genomics. Or let me say what I am doing in the genomics instead of someone else's problem. Let me tell you. So right now, what I am doing in my postdoc is actually I am dealing with some neuro data, which is coming from the different organ of the brains. And this is purely the DNA methylation sequencing data. And I'm looking how this sequencing data is actually different for the organs to organ. And my next way is to apply these machine learning algorithms and to predict the disease outcome if some pattern is specific to some disease. So how that data is specific to the disease, and it will predict if the data is coming from the real patient. That's what my ultimate goal is. And if it has the same pattern into that data, that means the probability or the chances of having that particular disease is much more into that data. So that will be, you could say, person-specific disease identification or the person-specific disease diagnosis. So that is the application of genomics data and having the machine learning. That's what I am doing right now into this. So I think it's enough to understand the role of machine learning into the genomics. Okay, so now we are coming to the type of machine learning algorithms. So there is generally three types. in some books you will say that association also a type, but in some textbook they categorize association as unsupervised learning. So mostly in the most of the textbook, it has been categorized as supervised learning, unsupervised learning, and reinforcement. So I think for the biological guys, supervised learning is enough to understand and to move further and to do their projects and other things. Supervised learning is enough. But unsupervised and reinforcement learning is also a part of machine learning algorithms. And when we are talking about the machine learning and their introductory things, we should know what is the difference between all these three. Okay. So now coming to the first one, which is unsupervised learning. So unsupervised learning is the classical definition is that it uses machine learning algorithms. Okay, that's obvious, to analyze and the cluster unlabeled data sets. So that means there is no human intervention. The data is not labeled, so it will automatically cluster that. So that means it is unsupervised. So the ultimate aim is from the data is that you have to discover some hidden pattern, but there is no need to the human intervention. You don't know exactly the pattern of the data. You don't label the data. So the main word is actually here is the label. I must have bolded or change the color of this unlabeled data. So that this is the most important word about the unsupervised learning. So that means it deals with the unlabeled data. So human does not interfere with the input data. It will be much more explained in the next example, whatever I'll give. So unsupervised learning models are used for three main tasks: clustering, association, and dimensional derivation. What I said that association is something sometimes in some textbook it is taken as a different type of machine learning, and in some textbook it is a part of unsupervised learning. So I have put it into the part of unsupervised learning. Okay. So what is clustering? So it is a data mining technique for grouping unlabeled data. So whenever it is unsupervised, you will see the term unlabeled data. So the data is not labeled here. So you don't know about the type of input data, or you could not, you know the type of input data, but you don't label it. You don't give some specific label to that data on their similarities or difference. So that means, let's suppose I have a huge data. So I'll try to cluster them based on their similarity or based on their differences into different domain. And you must have done this clustering while you are doing, hierarchical or other things. There is different type of clustering, hierarchical clustering, differential clustering, other things. You must have done this based on 16S RNA sequencing and other thing. You have clustered those organism or the microorganism. So based on to that. So it is similar to that particular example. So one of the example is k-mean clustering algorithm, which assigns similar data point into group, where the k value represents the signs of the grouping and granularity. That means if you have a data, large data, so let's suppose that you have 1,000 sample, if you want to cluster it. So, and if you have applied the k-mean clustering based on the similarity or difference, you want to cluster it to 3 groups. So here the k represents the size of the grouping will be 3, or you want to cluster it into the 5 groups. So the k means the value whatever and you want to group it. So this technique is helpful for market segmentation, image compression, etc. So that's why I said unsupervised is much more related to some other domains than us, but also it is clustering is also involved in the biological data also. Because whenever we are dealing with the image compression, or whether it is coming from the CT scan or MRI, other things, if you are dealing with those medical data, so here that clustering is actually involved. Now coming to the learning association, this is also a type of unsupervised learning, which uses different tool to find relationship between variable in the given data set. That means you have some data, it has different variables, and it will find the relationship between that variable. So this learning association is generally used with the market basket analysis and recommendation engines. So what I said, that recommendation about if you buy Apple iPhone, so they will suggest that, okay, buy Apple Watch also. Or if you buy shoes, they will suggest you to buy socks also. Similarly, this is also the basket analysis, where it has a probability that somebody who buys X also buys Y, where X and Y are the product or services. If you are going to buy beer, so they will suggest you to buy chips also. Okay, so that means here this probability is 0.7, because it's fine that everyone doesn't buy the chips with the beer, but it will give some probability of this. So this is about the learning association. For those who have watched Family Man 1 series, they will suggest you to see the Family Man 2 series also. That's how this learning association algorithm works. And now the next thing is coming, next part of this unsupervised learning is a dimensionally reduction. That means when you have some data and it has huge number of features. I mean, it has features which cannot be accommodated, or you could say it's a huge number of features you have. And in that huge number of features, some features are not much relevant. So what you will do, you will reduce the dimension of those particular features, because let's suppose that I have a methylation sequencing data. Let me give the example from this. I have a methylation sequencing data coming from 4 to 5 lakh of probes, but that doesn't mean all the probes are important. Around 5 or 6 probes are much more significant for a particular disease. 5 to 6 CPGs, you could say, or 5 to 6 sites of the methylation are much more specific to a particular disease. So what I will do, I will reduce the dimension to 5 to 6. It will take some features from the others and it will cluster it into this. And so I'll do the principal component analysis, or 3 to 4 features is enough to do my work. So that is dimensionality reduction. So that means it reduces the number of data inputs, or you could say the features, to a manageable size while also preserving the data integrity. But the data integrity is not lost. So let's suppose I have a 4 lakh features and it covers the 100% of the data integrity, but I have reduced this to the 5 to 6 features and still have the 95% of the data integrity. So instead of going to the 4 lakh, I will go with the 5. So that is how you reduce the dimension. So this is known as a dimensionality reduction. It is a very important concept in unsupervised learning, and the most of the time, 90%, you will see the principal component analysis technique as a part of dimensionality reduction. Often this technique is used to the pre-processing data stage, what I have said, such as when autoindicators remove noise from the visual data to improve picture quality. Okay, so whenever we do the recording, or whatever the image we are recording, we are getting, or the movie shooting, so they remove the noise from the background. So this is also a pre-processing or dimensional reduction example. I have given the example of the biological also from the sequencing domain. So that is also understandable. And now I am coming to the second part, which is supervised learning. So that means a machine learning approach that is defined by its users of labeled data set. What I said, that labeling is the most important part, or this is the most important word which differentiate between supervised learning as well as unsupervised learning. In the unsupervised learning, the data set will not be labeled, but in the supervised learning, the data set will be labeled. You already labeled that. These data sets are designed to train or supervise algorithm into classifying data or predicting outcomes accurately. That means you label the data set and then you will train it based on their features. So that will classify the data that predict the outcomes. Using labeled input and output, the model can measure its accuracy and learn over the time. So that's the same thing. So there is 2 examples of supervised learning. One is classification and another is regression. Okay. So this is about the supervised learning. So we'll see with some examples. So that will be much more easy. And then I'll take some questions if there will be any query related to that. So, okay, this is the example of supervised learning. So this is the data. I'm just giving very, you could say, scratch examples. So it will be better understand. Then we will try to relate it with the biological things. So that will be much more understandable. Okay, so this is the labeled data. So we have an input data set which has different, you could say, shape. So we have already labeled it with hexagon, triangle, or square. So this is the input data. So we will train the model. So everyone has some specific feature, like this square has. This is just a layman's example. Okay, this square has 4 lines. This triangle has 3 lines, and this hexagon has 6 lines. So these 6 lines, or the number 436, is actually a feature of these shape. Or you could say area. We could calculate the area, or we could, height or width, other things. So these are the features of this shape. So we have labeled, okay, if it has 4 lines, it has a square. If there is no question, please unmute yourself. So this means if I'm labeling this square as a 4, So, or this triangle is a 3, or this hexagon as a 6. So this is labeling. And based on to these features, I'll train my model. Okay, so it will learn from this input feature, input data, or the features. And then it has learned, the model has been built up. So then we will validate the model on some testing data. Okay, we will have some testing data. So in the supervised learning, you will always always differentiate your data into the training data as well as testing data. So you have the training data. Now you will test your model. You will test your model on some test data. So okay, it has not test data. So it has already learned all the features. So it will predict, okay, this is square and this is triangle. And in this way, your model is predicting the things. And here comes the statistic. You will see how much accurate or how much sensitive or how much specific your model is. Then you will evaluate your model based on some statistical parameters, for which we will talk about in later presentations. So there have been so many statistical parameters. So we will talk about those parameters later on. Okay. So based on that statistical parameter, we see how accurate or how best our model is. Okay. This is the example of a supervised learning. Okay. Now let me give an example from my PhD. So from my PhD, I have developed a prediction tool which classify the anti-tubercular peptide. That means a peptide which can kill mycobacterium, which is inhibitory against the mycobacterium. That is anti-tubercular peptide. So that classify that from the non-antibacterial or non-anti-tubercular peptide. So I already know that. Okay, when I have the data, I already know that this is the positive data. That means these peptides have been studied against tuberculosis. So that means they could kill it. So I already labeled them as a positive data set. So labeling could be on you could give 0, 1, you could give +1 or -1. It depends on you. So I have labeled them as +1. And I have some negative data set. So that has not been studied against anti-tubercular. That means they don't kill the tuberculosis or they don't kill the mycobacterium. So that is negative data set. So I labeled them as 0. So now my labeling is 1 and 0. I have the input data. I merge those data set. Let's suppose I have 100 peptides which can kill the tuberculosis or which can kill the mycobacterium, and there are 100 peptides which can't kill the mycobacterium. So right now I have 200 input data. I've already labeled them +1 and 0, 1, and then we'll extract from those peptides some features. So it depends how you are extracting the features. We'll talk about this tomorrow, how we'll extract the features. So based on to that labeling, it will and the feature extraction and selection, it will train our model and it will predict the outcome. So the outcome will be 0 and 1, whatever the testing data it will say. Because I already said that 0 is for the non-antitubercular or the non-antitubercular peptide, and the +1 is for antitubercular. So it will predict the score +1 or 0, and it will give some specific scores. So this is an example of supervised learning. I hope it's clear. Now coming to the supervised and versus unsupervised learning, how it has been differentiated. Okay, so supervised learning, here we have the input data. So we have already given the annotations. We have already given the annotation, or you could say labeled. So we have already labeled it. Okay, this one is +1 or something, whatever you want, +1, 0, 1, 1, 0, or whatever you want. Labeling could be depending upon your choice. So we have already labeled it. Okay, so and then we'll extract some features from this. Okay, the color should be red, the shape should be like this, the glucose content, it should be like this. So it depends on how you are taking the features from your particular data. And then you will train the model. So it will give prediction as a label. We have labeled is +1. So prediction, when we have the test data, so it will predict as a +1. If you have taken the +1, it will predict, okay, it's an apple. So this is the classical example of supervised classification model. And in the unsupervised model, we are not labeling it as something. We didn't label all these data. We just put the input data. So it will take the features from everyone, and then what it will say, okay, these are much more red. So this comes from a one cluster or one group. So it takes them into one group. But this is also similar to this, but the color is different, or you could say the ripening, other thing is different. So it will place it into the second group, and this will be placed into the third group. If I want to cluster it into the two, so what it will do, it will be clustered with this, and all this will be one cluster, and this will be one cluster, so two clusters. So this is how the unsupervised learning is actually comes into the pictures. Okay, so there is some question. Sir, can you please share your paper link? Actually, I am also working in mycobacterium, interested to read your paper. Okay, Okay. I'll share it with after this. I'll share in the chat box. Which one is better for predicting modeling, supervised or unsupervised? That definitely depends on your question, what you are asking for and what type of data you are. This cannot be explained into a one word which is better. It depends on your data. It depends on your question. What your question is. So most of the time in the biological data, supervised learning is enough too, because you want something, you want to either classify your data as a disease sample or as a healthy one, or something as a positive, like my question was to predict the peptide as antitubercular or non-antitubercular. So that was real classification supervised model. So, but if you have something where you want to cluster the peptides into the different domain, that's unsupervised. So it depends on what type of data you have and what your actual query is. So, okay, in the supervised learning, as I said, that there have been two types, classification as well as regression. So the classification problem uses an algorithm to accurately assign test data into specific categories. So that what I said, that if you want to classify something, what I have given in the last example, such as separating apple from orange, although the picture is from the apple from the banana. So this is the classification. And another example to classify spam in a separate folder from your inbox, what you already do. So you put some, let's suppose I'm getting some mail from Biotechnica or something, and I'm not interested into that. Initially, maybe in my master's or somewhere, I was interested in the Biotechnica. So I have given the subscription, or still they are giving me the mails. So what I will do, I'll mark them as spam. So what it will lead some specific words from the subject of the message or from the mail body of the message, and that will try to classify, okay, if it contains some advertisement or if it contains some word from the lottery and other thing, so that will mark that mail as a spam. So it will classify based on to that. So for this, what the Gmail or the mail thing, that will from the past data, we will classify, I'm not interested into these kind of mails. So if it is coming from some lottery and other things, so we everyone get these kind of mails. So we mark that, okay, it's a spam for me. Once I'll make it as a mark. So we have already classified that. We have already given a label to that particular mail. So this will be a data for Gmail or whatever the mail you are using. So it will read the mail, it will read the whole mail, and it will try to extract some features. So one feature could be a word of lottery, or one feature could be okay, you are going to win $1 million or something. So these kind of mail we get. So it will pick these word as a feature. And next time, if some mail is coming from that specific, if that is specific mail itself, the specific mail address could be a feature, or if it is coming from some another address, email address, but it has words like lottery, it has word like $1 million or something. So this will be feature of that particular mail, and we have already labeled that mail as a spam. So it will already already will classify as a spam, and it will move to your spam folder instead of the inbox. So this is a very classical example of applying machine learning, classification based machine learning into your mailbox. I hope I'm clear in explaining this example. Next is, there are so many classifiers. So linear classifier, support vector machine, decision tree, and random forest. These are the example of classification model. So I have not made the slides for this because this is much more based on, so the basic idea behind the classification I have given, but the difference between these common type of classification algorithm in what the algorithm or what the mathematics they are using into their background. So that's why I have not given I have not included a slide about the linear classifier, support vector machine, decision tree, and a random forest, because it will be too complex to understand. It will be too complex to think. So, but once we will do the classification tomorrow, I'll explain what is linear classification, support vector machine, and decision tree, and random forest. And if someone is interested, is much more, if someone is interested in much more mathematics, he or she could obviously explore it. Do you learn to write algorithms also for ML models? Definitely. That will be the next three days task. This is much more about writing algorithms, evaluating on your data, how you will extract some features, how will you prepare some models, how you will evaluate your models. Definitely we'll do that in the next 3 sessions. Okay. Next example is of the classification is I just have taken example from the credit scoring if you are using the credit card. So this is a graph here I've shown, and we have taken 2 threshold. Threshold is very important in machine learning algorithms. You have to give some threshold, whatever the value you are choosing as a threshold. So here we have chosen some threshold for the income as well as saving. We have chosen a theta 1 for the income and theta 2 for saving. So I want to classify them as a low risk customer or a high risk customer. So if someone has greater income than the theta 1, then our threshold value, let's suppose the theta value is for the income is 50,000 rupees. So if someone has income greater than 50,000 and his saving is actually, if suppose the theta 2 is 25,000, so if his saving or 20,000, so if his income is greater than 50,000 and still his saving is also greater than 20,000, that means the customer is a low risk customer. He will not be a fraud. He will return the credit card, whatever he has taken. So this is a low risk customer. But if his income is less than this theta 1, if his income is less than 50,000 and his savings are also less than the threshold value, so that means he is a very high risk, you could say, customer. This is how you will classify, how the credit card companies or the credit guys classify their customer into low risk as high risk based on their income and saving. So whenever we apply for the credit card, they always ask our payslip and other things. So that's how they classify low risk and high risk. So another real life examples for the classifications are face recognition. Okay, positioning, lighting, and makeup, hairstyle. These are also face recognition in the type of classification. Character recognition, different handwriting styles. Speech recognition is also another example of classification, as well as medical diagnosis, which is from symptoms to illness. You will classify the data. Now coming to the regression. In regression, this is another type of supervised learning method which uses an algorithm to understand the relationship between dependent and independent variables. So now we have to understand what is dependent and what is independent variable. So let's suppose that we want to classify whether the whether today's weather is there is what is the chances of, you could say, raining or something. So we'll see how much humidity is actually in the air. So that will be a dependent variable for a rainy day. So this is okay, let me bring something else for this. Okay, let's suppose we want to classify people on whether they are fat or whether, or you could say whether they are fat or not. So we'll see their obesity measurement, their size measurement. That will be a dependent parameter. That will be a dependent variable for our model. So this is an example of regression, which is a type of supervised learning where we understand the relation between dependent and independent variables. Another classical example could be percentage. If you want to see whether the guy has been passed into exam or not, so we could say the passing number 33 could be a dependent variable. So this I hope it's clear what is the dependent and independent variable. So some popular regression algorithms. So as I said, in the classification, there is support vector machine, random forest, linear classifier. So similarly, in the regression algorithm, there are 3 major categories: linear regression, logistic regression, and polynomial regression. So regression models are helpful for predicting numerical values based on different data points, such as sales revenue projection for a given business. So that means in the classification model, we just classify into 2 types, whether it's positive or negative. But in the regression model, we predict the exact number value. Like you see in if you are interested in stock marketing or crypto investment, you see that there have been so many platforms where they predict that, okay, it's going to be down by 6%, or it's going to be up by 5%. So they use the past data and they exactly predict, okay, today Bitcoin is 35K and most probably in the 1st June, it will be 36K or it will be 34K. So they try to predict the exact value. That is example of regression data. And the same thing applies to the biological data. In one of my PhD chapter, what I have done that I have some inhibitors against the mycobacterium. So that has already been studied. So these are the classical small molecule based drug molecules, you could say, or the inhibitors. So that had been already studied, and each molecule has some specific concentration. I mean, at that particular, let's suppose that I have a molecule and it suppresses the mycobacterium growth at 5 micromolar concentration. And suppose B molecule is something which suppresses at 6 micromolar, or C is something which suppresses at 3 micromolar. So now I have one kind of data where I have the molecules, and second thing is I have the values at that could be inhibition concentration. So what I will do, I'll try to extract the feature from each molecules. Okay, let's suppose this is just like a random example. If it has a benzene ring, that means sometimes if this benzene ring is associated with low concentration, low inhibition, low concentration, or high IC50, whatever you say. So it is related to this. Okay, that will extract the feature. Okay, benzene ring, or this particular group, or this methyl group, or whatever, this bond, or water chemistry you could consider. This is related to the higher concentration or the lower concentration of that particular molecule. So okay, now we understand our model has been trained on to that. If I'll check my model on some new analog or some new drug, it will try to extract the feature. Okay, if this has this feature, if it has the benzene ring, the regression or the concentration would be somewhere in between somewhere around 5 micromolar. So it will give the exact value, try to give the exact value. Okay, it has around 5 micromolar concentration. It will kill the mycobacterium. So this is an example of regression algorithm. So this is obvious that in the regression algorithm, so you have to much more data, and it should be regressively trained onto that. So the accuracy and precision is less in regression than the classification. If I have to classify my molecules based on only the inhibitor and non-inhibitor, it will be easy. But if I try to predict the exact concentration at which it will inhibit the mycobacterium, it is much more tough. I need much more data, much more features. So this is example of regression data. So another example could be, this is some students. So if we want to classify, we could classify them only on the pass or fail. But if you want to classify or regression would be predicting their percentage based on their performance. So we have to predict that. Okay, we know that there have been 10 students, and we know that okay, 5 will be passed and 5 will fail. But if I want to predict, okay, how many guys will get above 90%, so I'll have to regressively learn from their features. Okay, this guy is very brilliant in mathematics, science, and other things, and he scored 100% in math, but 80% in English. So overall, he will get 90%. So this is a classical example of classification versus regression. This is a random figure I have taken. This is random, or you could say, just to make you understand, the real data will not look like this. So here we are classifying some disease as well as healthy. It depends on the expression of gene 1 and gene 2. If gene 2 expression is much more, so this is disease. If gene 1 expression is more, it is healthy. So this is not a real data. It is just to make sure. But obviously, when we look at the real data, so there will be some red dots here also, and there will be some blue dots here also. So we will try to draw that particular line, which will classify most of the patients, which will classify most of the samples. It will never be 100% accuracy. We'll try to achieve 90%, 95%. We'll try to draw this particular line where it will classify this maximum number of with accuracy. This example of classification. And if we want to apply the regression, so here we have the model. So we know that this is gene 1, and if gene 1 is much more expressed, that means he is healthy. So if it's healthy, the survival chances is much more. So we'll try to predict the exact value or the line which has the minimum distance from these dots. So this example of regression. So this line has the minimum distance from all these dots. So this is much more mathematical. If I have included that, will be much more complex. So you just have to understand the regression. We try to draw the line which has the minimum distance or from all the points. So that means from this, from this, from this, from this, from this, all the points, this has the minimum distance. There could be another line like this, but it has the distance from these points are much more. So we'll try to draw that particular line which has the minimum distance from all the input data into the regression. And into the classification, we try to draw the particular line which will classify maximum number of input data, which will try to segregate maximum number of input data. Another could be the example of classification versus clustering. So here, these are some of the birds and mammals. So you will see that when I'm classifying it, it will classify as, okay, these are the ducks, hens, and goat, and I think cow. So classification is on the 5, it has classified. But in the clustering, it has clustered, that's into k-mean clustering. If I've taken 2, so all the birds are clustered into one group, and all the mammals are clustered into a second group. So you will see this is just 2 clustering. So this example of classification versus clustering. And if you see the classification versus regression versus clustering, so if we have much more data, and if you want to predict the height of that, that will be an example of regression. So if you want to predict the height of each sample, it will be the example of regression. And if you want to classify as an adult or as teenager or child, or you could say grown or growing, it is an example of classification. And if you want to cluster it, so this is cluster A and this is cluster B. So this is the difference between classification, regression, and clustering. Okay, so if there is any question till now, I'll happy to take the answer. Then we'll move to the reinforcement learning, which is.
Sir, repeat that previous slide. Can you repeat that previous slide? Yeah, this one.
So
Sir.
no,
after that.
Okay.
No, sir, after that. Yeah, this one. Clustering.
Yeah,
this one.
So as I said, that it depends on the query and the data. So let's suppose I have some input data of general people, and we have the height. We have the height measurement. Okay, we understand that this is the height measurement. So if we want to exactly know the height of someone else or something, so that will be a regression where we want to predict the exact height. So that will be example of regression. But if you want to classify them normally into adult or children or grown or growing, so that will be example of classification based on the feature. We'll see, okay, based on these height, this number, this is above 100 centimeter, above 120 centimeter, this is grown, below 120 centimeter, this is growing. So that means this is teen, this is adult. So this is example of classification. And another could be a cluster into this. So we have, this is unsupervised learning. We have not labeled it, but it will automatically, from the input data, it will automatically cluster it into as a one group, and this will be as a second group. That could be based on height. Another could be the cluster could be based on the gender. If you want to cluster it in the, so what it will take, this black and this boy, it will cluster it as a boy, and it will cluster as a. So this is, we are not giving label to this data. This will automatically cluster it based on the feature. This is the difference between the clustering. But here we will give the input data based on the height. We'll give this, okay, if this is something above 120, we will give it as +1, so it will be adult. And if it's below 120, we'll give it a 0 date label, and it will be classified as a teenager. Okay, so that's the difference between classification, regression, and clustering. If there is any other question, whatever I have said, you could ask. Or you could raise your hand, and I don't think so there is any specific question. Okay, so now we are moving to reinforcement learning. So this is not much more useful for you guys, but still, when we are talking about the introduction, you should know that. So the reinforcement learning is a part of machine learning. Here, agents are self-trained on reward and punishment mechanism. So here, there is nothing like labeling or unlabeling the data. There is two terms we use: reward and punishment mechanism. Okay, so if it is getting the maximum achievement, so here what it will 2 to 3 terms are very specific here. One thing is agent, who is going to learn. Another thing is environment, in which environment he is going to learn, and then there will be punishment and reward. So if he'll try to achieve by self-sustaining mechanism, he'll try to achieve the final goal, and once it will achieve the goal, it will be rewarded with some it will be benefited with some rewards. So that it will know what is the best possible path to gain the maximum reward or minimum punishment, or if it will not achieve the final goal, it will be punished. So this is actually majorly used in the robotics field, reinforcement learning. So through a series of trial and error method, an agent keeps learning continuously in an interactive environment from its own action and experience. The only goal of it is to find a suitable action model which would increase the total cumulative reward of the agent. It learns by interaction and feedback. So that means what I said, that it will try to achieve the final goal, final path, the final whatever is final query through its own learning method. This is the reinforcement learning. So this is not useful for the biological guys, but I have given. So one example could be, this is a real-time example, it will be much better. So this dog is, what I said, that there will be 3 to 4 terms: agent, environment, action, reward, and punishment and observation. So this is the agent. He will try from his own action what environment. So this, you could say, his master or his trainer, what it will throw this stick, and if this dog will catch the stick, will find the stick and return to this trainer, he will give something him to eat. He will give bone or something to eat him. So that and if he don't get it, he didn't get the bone, or maybe he could, in the circus you have said that maybe they could whip him or they could beat him. So that will be punishment. Or if there is no punishment, he will not give any reward, he will not give the bones. So once she will do 10 to 15 times, he will automatically understand that, he will automatically observe that, okay, whenever I am returning this stick to my master, I am getting the reward in form of a bone. So this is a classical example of reinforcement learning. So this is the summary of whatever I have talked. Machine learning, that means it is classified as supervised learning, reinforcement learning, as well as unsupervised learning. So in the supervised learning, you get the classification model, and it is used in the identify fraud detection, image classification, customer retention, as well as medical diagnostic. In the regression model, you advertise popularity prediction, weather forecasting, market forecasting, as well as life expectancy. In the biological data, you will see a number of papers coming from where from the cancer samples, they try to predict the estimated life expectancy, how much chances is there of the survival. So they do the survival analysis in the cancer data. This is a very growing field nowadays. So there you apply the machine learning regression models, as well as you try to predict the population growth. So in microbiology and other things, you could apply this regression model and try to predict the growth of the organism. So this is regression model. And in the unsupervised learning, so that could be dimensional division, there is a big data visualization, compression, as well as structure discovery. And the clustering, you try to segment the customer, or you try to cluster your input data. And in the enforcement learning, what I have talked, it is much more used in the robotics as well as artificial intelligence of gaming. This is much more involved in the gaming. So whenever you kill someone in the PUBG, you will get some rewards. So that is based on the reinforcement learning. So that's all from my side. If there is any specific query, we can discuss. And from tomorrow, we will be moving to much more hands-on. I'll try to see what kind of data initially we could take. I'll took some biological data, and we will try to extract some features, how we have to do the feature extraction, and then we will after feature extraction, we will try to apply different machine learning or algorithms. We'll try to develop models, and then we will evaluate our models based on their performance, and we'll see which model is actually better onto that particular data. So this exercise we will do in the next free session, I guess. So finally, I hope everyone will be having a much better understanding, and they will know how to implement machine learning onto their data and how to evaluate that. If there is a specific question, I would have to take them.
So if you have any question, you can directly unmute yourself or raise hand. Dr. Salman will answer.
Either I have not explained things clearly, or I have explained things very clearly that there is no question. So I'll classify this as only two. Whether I
So
have
my
explained
question
very
is that,
good, so there is no question, or I didn't
no, so my
explain it.
question is that, okay, whatever you talk about this, mostly the like regression, prediction, classification.
Please repeat your question. Please repeat your question. I didn't exactly answer.
Actually,
I
what you discussed regarding classification, regression, prediction, clustering method is like all
Yeah,
in machine learning. But
yeah,
these all method is in, people use in statistics, yeah, biostatistics methods.
obviously.
So
Yeah.
how the deviated, like, how can we say this is a machine learning? Because already these techniques we use in, like, people use in paper in statistical and biostatistical analysis. So how can we? Because like little bit confused now. About it. That's
No, so biostatistical method, you are not going to predict anything. The ultimate goal of the machine learning is that you have some input data. Okay, let's suppose that I have a data. What I have given the example, I have in the past, in the last 30 years, there have been around 300 peptides. To understand, I'm giving the example of the biology. It is 300 peptides, and that have been experimentally tested. That have been tested against the mycobacterium. Okay, they inhibit the concentration. They kill the mycobacterium.
okay.
So that has been already done. So just to see those experiments, it's not a very cheap experiments. They have 1 year or 2 year effort into saying that, okay, this particular peptide is actually killing the mycobacterium. It takes 2 to 3 years for one particular peptide, and a lot of cost also. So right now what I have done, okay, I have in the past 30 years 300 peptide have been identified which kills the mycobacteria. So what I will do, I will apply the machine learning from that data. What is the you could say features, or what is the specific about those peptides. I'll try to extract those features. Okay, if some peptides had, I'm just giving a random example. Okay, if some peptides had lysine in this particular ratio, this is much more efficient against the mycobacteria. Okay, my model has learned that. Now what I will do, instead of checking randomly from a plant, if I get 100 peptides, I'm not going to check it randomly from those 100 peptides. I already have my model. So I will put all those new peptides which has not been tested against the mycobacterium to the model. So it has already trained, it has already read the features from the past. So it will automatically classify those peptides which has not been tested right now in the experimenter. It will automatically classify 50 as positive and 50 as negative. So I'll get, okay, so it's better that these 50 are having much more chances to be a better antitumor peptide. And if I have something like a regression model, so I'll also know that, okay, this peptide, okay, in this much concentration, it could kill the mycobacterium. So my effort is very less. My effort is very less. Instead of checking those 100, I will just go with 4 to 5. So this is machine learning. And the biostat is actually will evaluate my model, how much efficient this model is. This is totally two different things. Biostatistics is just to evaluate.
No, sir.
how
Actually,
much
what you're taking, what you're saying, that is okay. I'm agree. But is what you're saying, feature selection, everything, same method do in the people do in the, because we read the paper by statistics. Yeah, like
Yeah.
we read in the paper.
So I'll answer your query in some unspecific manner. Okay, facts has been done for the past 30 years, but you are using the facts for your specific query. So STEM has been done for the past 20 years, but you are using TEM for your specific query. So similarly, these models have been doing in the past from several years, but you will apply this model for your specific query. I hope I'm clear now.
Okay, sir. Okay.
If I'm not clear, let's suppose that someone has checked the survival into lung cancer,
Actually, sir,
and they
we
have
do survival. Just actually, we do in some cancer data. Actually,
okay.
nasopharyngeal. So we use the like survival model in those things. Okay, we mostly same thing. We predict how the whatever variables, like you are in machine learning called the features. So like we
Features.
biostatistical tools, we call the variables or parameters, like maybe age, gender, maybe the grading up the like
Yeah,
cancer,
yeah.
tumor. So we do the same, input the data and predict the whatever responsible, important factor.
But
Even also, yeah.
if you figure out some specific pattern, if you figure out some specific marker, that will be your discovery, no? If you have from the feature, if
That
you have some specific marker, that will be your particular discovery. Okay, this feature or this marker is much more efficient for better survival. But now we have to target this particular CPG ID or CPG island or this particular site into the genome. That will enhance the survival. That will be your specific query.
Okay, sir. Thank you, sir. Thank you. Lots of thanks,
Yeah.
sir.
There are 2 to 3 questions. Sir,
Excuse
can you
me,
share
sir.
your model on Mycobacterium with us? Okay.
Sir,
So,
which
just-
type of
just go with
regression
my
model? Excuse me, sir.
Yeah.
Sir, which type of regression model have you applied in your PhD program? Peptide model.
In the regression, I guess the regression paper I have not published. It is just a thesis chapter, and I think I have applied many models and just to make my thesis chapter. That work has not been published. Regression paper. But the classification has been published, and in the classification, I applied every models, whatever classification is available, linear regression, research, as well as J48 random forest, and then some ensemble model. So that ensemble was the best one, and it has been published. So let me share in the chat box that particular paper. It will be better to understand if someone is willing to go with that. Someone asked it. Okay, this is freely available, so you could go on to that. So this paper actually concludes what I have shared in the chat box. This actually concludes against the Mycobacterium with the classification. For the regression, it has not been published. I didn't publish that paper. Okay, there have been. Let me take all other. Do you learn to write?
So which
algorithms?
kind of software did you use in your study, your PhD, Python or
So,
what?
yeah. Okay. So let me tell you. So for this, there have been three things. One is Weka classifier. You could go with the Weka. So, but now Weka has been outdated. So if you see today's, new papers, you will see R as well as Python. So it depends on the people's choice what you are using, whether you are going to use the R or whether you are going to use the Python. So that has some pros and cons.
Kind of data, specifically genetic data, gene data, which better software is this?
You could go with the R and Python. It depends on you in which you are coding.
Means both are suitable based on data, yeah.
Both are suitable on based on the data.
So then there is any issue with the data, like we have the very big data, so that's really useful for the R, yeah, like very small data, Python is better. What is that?
You can't say that. It's very little difference between the R and Python. Whatever the data we have both the language is very efficient to do the things. So I can't exactly answer that, which is better. In whatever language you are more comfortable is good, because same data, some guys used to prefer to work with the R, and in the same group, some guys used to prefer to work with the Python with the same data. So I can't exactly answer. It's dependent on which language you are more comfortable. Because the package is something, the same package they are using actually. Okay. In this
Sir, one more question.
In this
sir, why you choose classification rather than regression in your project, in your paper?
So
actually, your data type belongs to regression.
Yeah.
But you choose the classification model. Why?
No, not my data type was not, because there have been a lot of peptides where they have just mentioned that it kills that, but exact concentration was not mentioned into that. When I was looking for the exact concentration, the data was very diminished for the peptide in case of peptide. That's why I have chosen the classification. But in case of regression, there were small molecule based data where I have got thousands of data where they have given the exact concentration. But once I was just narrowing down the data for which I have the concentration, that data was limited. I was coming to some 100 or something numbers. I exactly don't remember, but the number was very low. That's why I didn't move a step further to go with the regression. Okay, let me answer the chat box also. If there is, do you learn to write algorithms? I have already answered. Are any branded tools using ML for medical diagnosis? Branded tools, I don't understand what do you mean by branded tools. There have been a lot of research is going on. There have been so many tools developed for the diagnosis, but branded, I don't understand what they mean by branded. I'm a non-bioinformatician. I'm good in computer science, Python, ML. Will I able to understand bioinformatics? Definitely, you are the, Ajay K. So you are going to be a champion because you understand. Right now, those who are flourishing in this field is actually the computer science guy. Because in the biology, they don't have to understand the biology. They collaborate with some biological guys, and the biological guys give the exact question. Okay, I'm looking for this question, and they just play with the data answer. So mostly the most successful guys are coming from the computer science in this field. When should we go to machine learning? When should we go to deep learning? Machine learning, I have talked everything. I didn't think so. I have left except the mathematics behind the random forest SVM and everything I have covered. Deep learning, we are not going to talk. Deep learning itself is a very complex and another topic. So deep learning has not been assigned to me. So I'm not going to talk about the deep learning. So for the machine learning, you could say hands-on, we will go to from tomorrow. And all the introduction, the basic concept I have given, except the mathematical equations. This is the answer for Jinkon. I don't know why he said that when should we go to machine. So can you share? Okay, thank you. If there is any other question, please unmute and ask.
Sir, you presented wonderfully. So there is no room for questions, and this is a great presentation. I hope participants enjoyed your presentation, and we are looking forward to your hands-on session from tomorrow on different algorithms of machine learning. So from tomorrow, Dr. Salman will deliver hands-on session on these different algorithms of machine learning. So someone is saying, I would be very happy if you can address deep learning in future. So we will try to incorporate deep learning, but it will require another 15 days in addition to this 1 month bioinformatics workshop. So
because it will be tough for me to evaluate all the model for the linear and classification regression in the 3. But I'll try to give my maximum within the 3 days. But deep learning, I think it's not possible to cover in the next 3 lectures.
So from tomorrow, we will have a hands-on session on this machine learning algorithms. And thanks, Dr. Salman, for making this workshop a great platform for learning. So thanks, and we will meet again tomorrow. I will share the video recording of this session with you as soon as possible. So thanks, and also kindly visit our web page decodelife.co.in. We have released the details of our upcoming workshop, that is drug discovery and design. So that will be again a 1 month bioinformatics workshop, and we will cover everything from scratch to advanced of drug discovery and design. So Dr. Salman will be also there. So please share this information with your contacts and friends who are interested in drug discovery and design. And also we invite you to be a part of this. Fee is again same ₹1,200 for Indian participant and USD 25 for international participants. So with these words, now I will seek permission of Dr. Salman for ending today's session.
Thank you so much. Bye. Have a good day, everyone. Bye.
Yeah.